So just to recap where we left off yesterday when the world was different. Okay. We had looked at the sinusoidal function. That takes this form. Okay. And we looked at what each of the parameters, A, B, and D, represented on the graph. Where do they show up in the graph? Okay. So can you guys just remind me, what does the value of A tell us? What is A? Yeah, the amplitude, correct. Okay, and what's the value of D? The midline, correct, of the graph. And what about the value of B? What does that tell us? Yeah, it relates to the period. It's not exactly equal to the period. What it actually is how many periods do you get in 2 pi, right? So when B was 3, we saw 3 periods within 2 pi, okay? Which means the period was 2 pi divided into 3 chunks. And so that is how it relates to the period. Period is 2 pi divided by B. Okay? So let's approach this question here. Determine the amplitude, period, median, domain, and range of the graph of the function y equals sine 1/4 x minus 3. Okay? Now you could graph this and look at it on graphing calculator, but knowing what we know from yesterday, that's going to take longer. And also, I may do something like, instead of giving you 5, 1/4, and -3, give you letters instead. I don't think you're sharing your stuff. I'm not? I'm looking at your... Yeah, we're just seeing you. Oh, shoot. Okay, hold on. I thought I did, but thanks for telling me. I have to pause the recording. All right. So knowing what we know from yesterday, okay, it's actually faster to use that knowledge to determine all of these things than to graph this thing on a calculator. Okay, if we're looking at y equals 5 sine 1/4 x minus 3, well, what's the amplitude going to be? Yeah, the amp is 5. What's the midline going to be? Or 3, midline or median, the same thing, is -3. What would the period be? How would you figure it out? The B value is 1/4. How do you get the period from the B value? 2 pi divided by 1/4, or 0.25. Yeah, so if you put 0.25 in there, that's fine. If you put it in as 1/4 in your calculator, you've got to do it in brackets. 1 divided by 4. Okay, what do you get there? 8 pi or 25.1? Yeah, either of those is fine. Okay, so that's the amp, the midline, the period. Okay. Domain. Now think about what this looks like. This is a wave. Does it ever stop going left? No. Does it ever stop going right? No. Okay, what's the domain? Yeah, x is an element of the reals. Okay, now for the range, you really have to imagine the midline and the amplitude. Okay, the middle of the graph is at -3. So what I'm going to do is I'm just going to draw, here's my y-axis, here's -3. Okay, that's the middle. And once you do this a few times, you actually don't have to draw it out that much because you're going to be able to visualize it in your head. Okay. What does the amplitude tell us about the graph? Got the midline, and then the amplitude is what? How high and low it goes from the midline. Yes. Okay, so how much up from the midline and how much down from the midline is it going? It's going up 5 from -3 and down 5 from -3. So if the middle is -3, how much is up 5 from -3? 2, exactly. So it's going to go up to 2. How much is down 5 from -3? -8. And then this, I guess, would be 25 point whatever, 0.1, right? Because that's one period. And that will be able to tell you your range. Okay, so your range is going to be the minimum is -8. The maximum is 2. In general, your max is always your midline plus your amplitude, because you start in the middle and you add your amplitude. Your minimum, you start in the middle and you're subtracting your amplitude. You're going down by your amplitude. And that's true for all sinusoidal functions. Okay? All right, so we did some analysis here where we had a function and we had to determine all of these things about it. Now we're going to go the other direction. We have a graph and we have to come up with an equation for the graph. Okay, so determine the sinusoidal equation in the form y equals a sine bx plus d for the following graph. Verify your equation by graphing the equation in your calculator. Okay, so this is always a good idea. We're not going to do this today, but you guys can obviously do this yourself. And when you are thinking about doing this, you have to remember 3 parameters that relate to 3 things: amplitude, median, period. So when you're analyzing your graph, you need to look for those 3 things. Okay? Let's start with the median. What is the median of this graph? Can you see where the middle is? Yeah. Is it at 1? The middle? Yeah, it's at 0. It's right here. So this is your median. Okay, now you can see very clearly in this particular graph where the middle is. And that's because, like, the blocks are very clear. Each little block is worth 1. The scale is very clear. So you can just look at it and you could tell. But sometimes that's not the case. Sometimes, like, if this was, I don't know, like 200 and this was -76 or something, you wouldn't necessarily be able to tell exactly where the middle was. So how could we calculate the middle? Yeah. Yeah, it's an average of the lowest and the highest. It's the middle of the lowest and the highest, so it's an average. How do we average 2 values? We add them and divide by 2, right? So lowest plus highest, or highest plus lowest, 4 plus -4 over 2. Well, that's 0 over 2, which is 0. Okay? What is the amplitude of this graph? Yep, it's 4, exactly. So that's right here. You could see it again, that it's 4. Right? But again, if you can't see exactly what that is, right, it's going to be half the distance from the max to the min, because it's from the middle to the max or the middle to the min. When you're looking for a distance between 2 values on an axis, that's a difference. So for your amplitude, and I'm just reminding you this so that if you can't see from the scale, you know what to do. It's your max minus your min over 2, right? So for minus negative 4 over 2 happens to be 4. Okay, and then finally our period. So if I start right here, because that's at 0, that's kind of a nice place to start on the x-axis. And if I look at the point in the cycle, right, I'm on the median, or the midline, and I'm on the upswing. So if I look again, okay, I'm going up, I come back to the median, but now I'm on the downswing, that's no good. And then I come back up to the median, and here is at the point where I'm back there up on the upswing again. So that's one period. Okay, what's the length of that period? What's the length of the period? 12, yeah. Okay. So, putting this all into the equation, well, we know the amplitude is the A value. The median is the D value. Now the B value. So we have this relationship where period equals 2 pi divided by B. We know the period. 12 equals 2 pi over B. Okay? We got to solve for B. Okay, so this is actually kind of like solving a rational equation. Look at that, there's a variable in the denominator. Anyway, it's not as complicated as that, thankfully, as the ones we saw earlier. But to solve this equation, having the b in the denominator is not very nice. So to get it out of the denominator, we can multiply both sides by b. Right, and then these cancel. And then what I'm left with on the left side is 12b equals 2 pi. And then to get b, what do I need to do? Divide by 12, yeah. Okay, now we end up with b equals 2 pi over 12. And that was the period, right? So we have this thing that says period equals 2 pi over b, and we ended up with b equals 2 pi over 12, which happened to be the period. So when I isolate this equation for b, basically what happens is that these swap places. Can you guys see that? Now, if you can remember that, great. The problem is that you're only given the one that I boxed in on your formula sheet. You're not given the other version. So if you can't remember that, you need to know how to solve for it. Does that make sense? Yeah? Okay. Now you could also reduce this if you want, right? 2 over 12 is 1 over 6. So this becomes pi over 6. And that is your b value. If we're going to put this all together, and it takes the form y equals a sine bx plus d, well, we know that a is 4, so y equals 4 sine, b is pi over 6, x, plus d is 0, so you can just leave that out. If you want to put in plus 0, that's fine, but you don't have to. Okay, any questions with that so far? Awesome. Okay, so I'm going to give you guys maybe 5 minutes to work on these two and this one. But I did kind of ask you to look at this last night, so I'm not going to give you a ton of time because I want to start talking about some applications, okay? And I'm going to pause the recording actually. while you're working. Okay. So I had a request to talk about question 2. Okay. Oh, question 2. Question 2 is an example where, remember I said how actually these sine functions have another parameter called c that we're not going to discuss in this course? Well, this is an example of this scenario where we have y equals a sine bx plus c plus d, right? So the c value here is negative 3.14, which is probably negative pi, okay? This is where if there is a c value, it will be given to you and you will never be asked about it. So that's what's going on here, okay? And basically what that does is it's going to move the graph from side to side. And so the effect of that is, do you know how normally the graph starts on when x is 0, where the graph is on the upswing, like this? Normally the sine graph starts on the upswing. Okay, this has shifted the graph to the right. Because now it's not starting on the upswing anymore, it starts on the downswing. So that's the effect of that minus 3.14. That's what it does. But you guys don't need to know about it, or you're not going to be asked about it. Okay? Okay, so determine the equation of this thing. All right, so this is one where we may not be able to see exactly what the midline and the amp is exactly. So it's probably a good idea to figure out the max and the min. So the max, it looks like here, is at, what is that, -1? And the min is at -5? Is that right? I think so. Yes? Okay. Okay, so if we're trying to figure out, let's say, the midline. Let's go with the midline. I like doing the midline first because then I can get a sense of where's the middle of this graph. Can you guys tell me where's the middle of -1 and -5? What's the middle of that? -3. Yeah, so here's the midline. So that's -3. So D equals -3. Okay, what about the amplitude? Amplitude is what's the distance from the midline to the maximum or the minimum. So here's the midline, here's the maximum. What's that distance? Yeah, that's 2. Okay, and that's the A value. Okay, and then finally, the period. Yeah, the period's 4, because here you can see when x is 0, it's starting on the downswing. And the next time it's on the downswing at the midline is at x equals 4. So the period is 4. We just saw from the previous example that b is 2 pi over the period, which is 2 pi over 4. Okay? Now, I had questions in my last class. Nobody in this class asked me about this, but in my last class, should I leave that as 2 pi over 4? Should I leave it as reduce the 2 over 4 and write pi over 2? Should I enter it into my calculator and get 1.57? What should I do with that? And the answer for this course is I don't care. If you're planning to do 30-1, you should leave it like this, pi over 2, because that's what you're going to be expected to do next semester. So get into the habit of doing it now. Yeah. Is the amplitude -2? So the amplitude is not -2 because I can see why you think it would be because it's going down first. But actually, and that's another way of interpreting this function, but the reason why it's going down first is actually because of this shift to the right from the c value. So this c value shifts everything to the right.
Well, if you get, don't you subtract the number?
So, okay, yeah, so if we did that, right, if we looked at amplitude as max minus min divided by 2, if we did it that way, Max is -1 minus -5 over 2. When you subtract a negative, that actually becomes positive. So 1 minus -5 is actually +4 over 2, which is 2. Does that make sense? Okay. All right, sweet. Okay. You guys need to do this for homework. Page 528, numbers 1 to 3, 5 to 7, and 9. Okay? Yes? You're just stretching? Okay. So the last thing that we're going to talk about in this unit is solving contextual problems. And we actually kind of briefly touched on this yesterday, where we were looking at some graphs that had a context. But we're going to go in more depth here, and we're actually going to look at the equations, because now we know a little bit more about what these A's, B's, and D values mean. Okay, so we can dive a little bit deeper. Okay? So, here's an example. The far north is called the land of the midnight sun for a good reason. During the summer months, in some locations, the sun can be visible for 24 hours a day. That's because you're at the very top of the earth. The number of hours of daylight in equivalent Nunavut can be represented by the function y equals 8.245 sine 0.017x minus 1.393 plus 12.585, where x is the day number in the year. Okay. Question 1. How many hours of daylight occur in Iqaluit on the following days? The shortest day of the year and the longest day of the year. Well, if you were to imagine what the graph would look like, what would you be looking for on the graph that would correspond to the shortest day of the year in terms of the number of hours of daylight? What would you see on the graph for the shortest day of the year? What do you think? Yeah. A minimum point. Yep. And if you're looking for the longest day of the year, a maximum point. Yes. Okay, so before we even graph this, we're going to graph this in a moment. But before we do, I want to do a little bit of analysis here. Okay? What is the median of this function, or the midline of this function? Yeah, it's this. Okay? What does that tell us about the number of hours that the sun can be visible throughout the year? It's the average. Yes. This is the average number of hours of sunlight throughout the year. Okay? 8.245. What is that on the graph? The amplitude. What does that tell us in the context? On the graph, it tells us how much does it go up from the midline and how much does it go down from the midline. What does it tell us in the context? Yeah. Yeah, how much does it go, how many hours of daylight does it go up from the average? And how many hours of daylight does it go down from the average? So if the average is 12 point something hours, and it goes up by 8 point something hours, well, 12 plus 8 is what? 20. So if the middle is 12 and it's going up by 8, it's going to be 20 point something hours is the maximum. Does that make sense? Yeah. And if the middle is 8 and it goes down by, no, the middle is 12. The middle is 12 point something. It goes down by 8 point something. 12 minus 8 is what? 4. So that's going to be the minimum. Does that make sense? Yeah? Okay, now, this is the amplitude. This is the number of hours it varies from average. Okay, so if the middle is 12 point something, it's going to go up by 8 or down by 8, and anywhere in between. Okay? We're going to get to this in a second, and in fact, we could figure that out right now. We don't have to graph it. The shortest day is going to be, well, what's the average? The average is 12.58. It's going to go down by the amount it varies, minus the amplitude. So we're going to go 12.585. We're going to subtract the amount that it varies by, minus 8.245. Whatever that is, 4 point something. I don't know what it is. You guys tell me. Yep. 4.34 hours. Okay? Shortest day of the year, by the way, is the min value. Yeah. Longest day would be the max value. Right? So we're going to take the average again, but this time we need to add the amount of variance. We're going to add the amplitude. And that's 12.585 plus 8.245, which is 20.83 hours. That's pretty nice. Pretty long day in the summer, but pretty short day in the winter. Okay, let's talk about the period. How would you figure out the period of this function? Yep. So let's just think, period is equal to what? It definitely has to do with this, right? Yes, the b value. But how does it relate to the b value? 2 pi divided by, that's right. So it's going to be 2 pi divided by 0.017. Okay, so someone tell me what that is. I can't do that in my head. Not that good. Yes. 369.5 something, 0.6. Okay. So you guys, I'm going to say that this value was rounded and this is slightly off. What do you think the period should actually be? 365, yeah. Yeah, because it's a year, right? So if we actually put in b equals 2 pi over 365, what decimal do you get? 2 pi over 365? I think that 0.017 is a rounded value. That's my guess. Does it round to the nearest thousandth to 0.017? Yeah, it does, okay? So that, you have to use a little bit of common sense. So the period probably is meant to be 365 days. Why is that significant? Days of the year, yeah, right? So 365 days in a year, exactly. Okay? State the domain and range within the context of the question. Well, let's start with the range. right? If you look at what each variable represents, and with context, sorry, I didn't do this with this question, but I did emphasize it in our first unit when we were looking at other types of relations and functions. Be really clear on what your x represents, and be really clear on what your y represents. X is days of the year. Y is the number of hours of sunlight. Okay, so if we're looking at our range, what's the minimum number of hours of sunlight? What's the maximum number of hours of sunlight? Yep. Yeah, it's this one. Yeah. Yeah, so it's anywhere from 4.34 hours all the way up to 20.83 hours. That's our range, because Y represents hours of sunlight. So 4.34 less than or equal to Y, less than or equal to 20.83. X is a day in the year. What could X be? Yeah. Yeah, now I'm trying to think about this, whether it's 0 to 365. I think I'm going to say it's 0 to 365. What's that? No, but I don't think that, I think that we're going to say that it's continuous, because if you're on day 0.5, that's like January 1st at 12 p.m. So the end of the first day would be the end of January 1st. Does that make sense? You can have part of a day. Yeah?
Should we write it as just greater than and not?
No, I would say that the days, would you agree? I think that days goes from 0 to 365, because if you're at January 1st at 12:01 a.m., you haven't gone through a full day yet, right? You've gone through a very small part of a day. So you haven't completed the first day yet. So I would say that domain should actually be 0 to 365. But if you put a 1 there to 365, you have a really good understanding of the question, and I would probably give you full marks.
You could also think about it this way. If you're at 12 a.m. on January 1st, in some places you can see the sun at 12 a.m. It's called the midnight sun up in the north. So you can have a value, start having a value for daylight starting right at 12 a.m.
Okay, questions with that one? No? Next. The Ferris wheel. The Ferris wheel, okay. Oh no, this isn't a, yeah, this is the Ferris wheel example. I should play a video of a Ferris wheel. I'll do that tomorrow. The equation h equals 15 sine 0.095t minus 1.56 plus 26 represents the height of a car as it turns on a Ferris wheel. T represents the time in seconds, and h is the height in meters. Okay, so before we even start looking at this, we're going to do this. Here's the ground. This is my very, very, very bad drawing. Now when the Ferris wheel, like there's like a little thingy like that, like a fulcrum, yes? And then like, okay, so the Ferris wheel doesn't like touch the ground, right? Because then you'd hurt yourself if you touch the ground. So usually there's like a couple steps that you have to step onto, and then the wheel goes like that, correct? Is that roughly what it looks like? I think so. So if you're sitting on a Ferris wheel, like here's the little seat, and here you are. And then you go round and round and round and round and round and round and round. Okay, so you get on the bottom, and your height increases until it gets to a maximum, and then it goes back to the middle, and then it goes down to the minimum, and then you keep going round and round and round and round and round. Does that make sense? Okay. Okay, so the equation, here's the equation. Okay, what is the maximum? Well, let's actually think about this for a second. What's the median or the midline of this graph? 26. Okay, what is that going to correspond to in this picture? Like if I put like an X, Y, yeah, it's this height right here, right? This is the middle of where you could be. This is your middle height. Does that make sense? Yeah? So this is 26. Well, I can't write it there. So when I'm doing these, by the way, I don't tend to like go according to the chart. I look at the equation, and listen, we can graph this too, and maybe we'll look at this one on a graphing calculator too to see what it looks like. And I just pick apart, okay, what does this tell me? And I tend to start with the median. That's just my personal style. What does this tell me? And what does this tell me? Okay, so the 26 is like, where's the middle point where I could be at any time? Okay, what does the 15 tell me? It's the amplitude of the graph. Where would the 15 show up in this picture? If this is the middle, and I go up to here, how would the 15 be significant? Yeah. Yeah. Right? Here's the middle, here's the maximum height. This is the 15. Okay, so from the middle to the top, that's the amplitude. Where does that show up in the circle? What part of the circle is that? The radius. Yes. Okay. Well, if this is 15, so I start at 26, I go up from 15, well then what's this maximum height up here? My middle is 26, but then I go up by 15. How high am I? 41, yeah. This is at 41. And then I could also go down by 15. This is also 15. So what's my minimum? If my middle is 26, I go down by 15? What's 11? There you go. Okay, we're figuring out all sorts of stuff here. Okay, so let's actually fill some of this stuff out. We got our maximum. The maximum is 41. What does that mean in the context of the question? If you were describing to someone what that would look like in this context. Yeah. Yeah, it's the top of the ride, right? It's the max height of the Ferris wheel. The minimum is at 11. That's going to be the min height of the Ferris wheel. Okay. The median. Median is at 26. Okay. What is the 26? How would you describe that? Yeah. So it's not kind of halfway up. The way that I would describe it, it's a hard thing to describe. Like you can all see it. I would say that it's the distance or it's the height of the center of the wheel above the ground. Does that make sense? Yeah? Because like here's the ground, here's the center of the wheel. This is 26. It's the height of the center of the wheel above the ground. Okay. Amplitude. What's the amplitude? The amplitude is 15. And where does that appear on this ride? The radius of the wheel. Okay, and then the last one we haven't addressed yet, which is the period. What is the period? Or how would you figure it out? Yep. How'd you get 30? Ooh, it's not related to any sort of heights. It's related to this guy. Yeah. Okay, so yeah, that sounds more like it. How did you get 66 point, whatever it was? Oh, you did it on your graph. Okay, yeah, so you could certainly graph it, and then you could look at 2 points that are the same. How could you get it from the equation, though? That's totally valid. You can definitely do it that way. Yeah. Almost, the reverse. Okay, period is 2 pi divided by 0.095. And that, does that work out to be 66 point something? 66 point, what? No? Yeah? 0.4? Okay. What does that tell us about this ride? Yeah. Oh, 0.14, thank you. Okay. What does that tell us about this ride? Yeah. Yes. How long does it take? And time here is in seconds. How long does it take in seconds to go all the way around once? So time in seconds to go around once. Okay? All right, so I'm just looking at the time, and I think what I'd like to do is skip this one. I'm going to ask you guys to do this number 2 for homework, because what I want to do is while we're together, I want to explore some applications with you that are different. Oh, wait, this is another Ferris wheel. What do I want to skip to? Another Ferris wheel. Let's skip to this one. Yeah. We're going to skip to page 55. Okay? Because the next few questions are all about Ferris wheels. And once you can kind of understand what the values in the equation mean to a Ferris wheel, it's kind of the same for all of them. Yeah. Okay. So what I want to do is I want to talk about another question, which is this one. Okay? This question is all about, and this is actually a standard of excellence question. How could you describe what would happen to can you describe what would happen to the graph if we changed something? Okay? So the average monthly temperature in Edmonton can be modeled in the graph below. How would the graph of the function change if you were studying the average temperatures in San Diego, where the average low is 14 and the average high is 21 degrees? Okay, now this is kind of like a compare question. And I gotta tell you that I made these notes before they introduced the written response question on a diploma exam. So you guys on the back of your formula sheets were given a list of directing words. And I know that this is now kind of irrelevant because diploma exams were just made optional, but some of you said you might want to write them, so I'm going to talk about this anyway. This would be kind of like a compare question, okay? Tell me what would happen if we changed this situation, compare, so that we were now in a different city. Instead of being in Edmonton, we are now in San Diego, where the average low is 14, the average high is 21. Okay, now when you are thinking about talking about comparisons, you want to keep in mind you have a function and that function has parameters. How many parameters are we dealing with for a sine function, at least that we're responsible for in this course? Yeah, 3. What are they? What are the 3 parameters that we speak to in this course for a sine function? Amplitude, period, and midline. Correct. Okay, so when you are approaching a question like this, you want to think about that and think, okay, if I'm going to talk about how things are going to change, I better think about those 3 parameters. And I better think, will the amplitude change? What's the amplitude in the context of the question? Will the period change? What is that in the context of the question? Okay, will the midline change? And what is that in the context of the question? Okay, so here we have, this is the monthly temperature in Edmonton. It can be modeled with this function. I think we looked at this one already, right? So the low is -12, the high is 24. Okay, yeah, we looked at this one yesterday. Okay, what's the midline of this function? What's the middle of 24 and -12? 6, yeah, good. We did look at this one yesterday, right? So here's the midline here. This is good. This will speed things up a little bit. Okay, so the midline is 6. And what does that represent? What does that tell us about Edmonton? Yeah, it's the average temperature. Correct. Okay, what is the amplitude of this function? $18, yeah. So basically, throughout the year, the temperature, you guys are going back, can go up 18 degrees or down 18 degrees from 6. So that's the amplitude. That's the amount of variance from the average. How much does the temperature vary from 6 degrees? It can go up 18 degrees, it can go down 18 degrees. Okay, what's the period of this function? We're looking at average temperatures throughout a year. 12 months, exactly. Because after 12 months, the temperatures tend to repeat themselves. So the period is 12 months, or 1 year. Okay, now if we go to San Diego, okay, the average high is now 21. The average low is now 14. That's about here. 21, 14. What's the middle of 21 and 14? What's the difference between 21 and 14, by the way? How much do those differ by? 7. So half of 7 is like 3.5, right? So like 3.5 up from 14 would be like 17.5. So this is now going to be the average. Okay? And it's going to go up to 21 and down to 14. Does that make sense? And so it's probably coldest in the winter again, right? In San Diego, that tends to be, they have the same winters as we do. It's not like Australia where the summer is the winter and the winter is the summer. So it's going to start here. This is going to be the maximum over here. Right? What's the period of this graph going to be? 12 months, yeah. We have the same year here in Edmonton or Calgary than we do in San Diego. Okay, so it's going to look something like this. Okay, midline is 17.5. The amplitude, it goes up or down by 3.5 degrees. Or 3.5. Okay, what happens to the period? Stays the same. It's still 12 months because we're still talking about We're still talking about a year. Okay, so when you get these compare questions, and it can be for this type of function or other types of functions, it's really helpful to think about what are the parameters of the function, and am I speaking to each parameter? Okay. And I think that I'm going to leave it there today because, well, yeah, I'm going to leave it there today. I'll tell you what. Here's what I'm going to get you to do in the last couple of minutes is let's go back. And I know I'm jumping around a little bit, but that's because I wanted to expose you to a few different types of applications. Let's go back. And you guys now try and do some of these Ferris wheel questions yourselves, starting on page 52. Okay, so there's question 2, and then there's a couple more on the next few pages. Okay, and then tomorrow we're going to finish up all of this sinusoidal application stuff. Yeah. Thank you for reminding me. Yes, I'm going to hand back your quizzes right now. For those of you that are home, I'm going to sign off now. What I'll do maybe is I'll take photos of your quizzes and I can send those to you.